Good morning. It's Tuesday, November 14th. That'd be 8 days till my mom's birthday. And I hope you guys have gotten your cards in the mail. We're going to talk about lesson 4.4, the slope formula, talking about linear functions still. It says, why do we learn this? What's our objective? We're going to find the slope by using the slope formula. Slope formula. Before that, we're going to have a little humor. Baker told his assistant to have, H-A-L-V-E, the filling recipe for a cake. When the baker asked for the filling, the assistant replied, "But I ate it." "Why did you do that?" demanded the baker. "You told me to have it, H-A-V-E. All right, well, back to our lesson. It says you can use the slope formula to find how quickly a quantity, such as the amount of water in a reservoir, is changing. Previous lessons, we talked about a constant rate of change of a line, and we saw how to find the slope of the line by using its graph. There's also a formula that we can use, which usually represented by m. We're going to use the formula y equals mx plus b, where the slope is represented by m. The way that we're going to find the slope, given 2 points, is, in the example in the notes in the middle of the page, it says if we have the point 2, 3, and the point 1, 4. We want to do this. We're going to take the change in the y values, as I have been, I guess, basically harping on all this time. M is the change in y over the change in x, and the change in y indicates difference. So we're going to take those two y values and we're going to find their difference. I like to do this. The slope is equal to y2 minus y1 over x2 minus x1. Notice this is the same ordered pair, and this is the same ordered pair. Thus, yielding, doesn't matter which one's y1 or y2, but as soon as I say 4 minus 3, I must do the related points. So if I put 4 first, that comes from this point. 1 needs to be my first x value in the denominator. So 4 minus 3 over 1 minus 2. Calculating that, we get 1 over negative 1. Our slope for these 2 points is negative 1. In example 1, we see the slope formula. Once again, slope is equal to y2 minus y1 over x2 minus x1. I would like you to do the check it out problems 1a through 1c. And what I really hope that you will start to do when we begin this is something like this. I'm looking at example 1. I have the ordered pair 4, negative 2 and negative 1, 2. As we're getting used to this formula, I would hope that you could do something like this. If this is x1, this is y1. That makes this x2 and y2. As I said before, it doesn't matter, but we want to make sure that we get those in the correct order, because if we get them switched around, we get the wrong answer. And we know in math, we're looking for the right answer. So looking at this formula again, we would have 2 minus negative 2, must keep track of those signs, negative 2 for y1. In the bottom, because we used 2 first, we're going to use negative 1 first. That's our ordered pair, x2, y2. Negative 1 minus 4. Recall, it is always a difference. It's the difference in the two values. So 2 minus negative 2 is the same as 2 plus 2. And in the denominator we have negative 1 minus 4. We have a negative 4/5. Our slope, negative 4 over 5. Falling 4, running 5. So what I'd like you to do after viewing the first part of this and doing check it out 1A and B and C, I want you to come show me the slopes that you got for those problems. Right now I'd like you to take a look at example 2. It says sometimes you're not given 2 points to use in the formula. You might have to choose 2 points from a graph or table. In example 2 it says each graph or table shows a linear relationship. Find the slope. So in looking at this line that they gave us, we carefully note where the line passes through the grid exactly. And we can see that those 2 points could possibly be -2, -1, and 2, 2. And then all we need to do is take our formula, y2 minus y1 over x2 minus x1, and calculate that slope. We could do that quickly. Both x2 and y2 are 2. We need to be careful to keep track of that second value. So 2 minus -1, the y value, over 2 minus -2. Evaluating and simplifying that, we get 3, 4. And if we look back to the graph, we can see this. Rising 1, 2, 3, running 1, 2, 3, 4. Matches our line. It's a constant rate of change. We've calculated it. That slope applies to every point on the line. I'd like you to do check it out 2A and 2B. Notice that the same applies when we have a table. In part B of example 2, we would just choose 2 of those ordered pairs and use them in our slope formula. Please do check it out 2A and 2B and bring me those solutions so I can check them off. So we can see in example 3 they're talking about environmental science application. We have water in a reservoir in thousands of cubic feet over time, and we can see the level decreasing. We see there's an obvious negative slope. They're going to find that constant rate of change, which perhaps is not so constant. I would believe that the level would go up and down at different rates. However, I have this example for you. Cost of electricity over time in months, and we're talking about the total bill. So obviously it's going up and at probably a constant rate since we pay about the same each month. What we want to do here though is tell what that rate of change actually is indicating. So when we find this slope, I'm going to take my first value 24, second y value 12, and I've got my x values 4 minus 2. Let's simplify that. 12 over 2 is equal to 6. Well, 6 what? Because it's 6 over 1. This is the change in y over the change in x. We can say that it is changing. The y value represents the cost, $6 per time being 1 month. $6 per month, and that's what the slope is representing. You can look at example 4 and realize that obviously we're going to take this to a different level. We've been talking about equations of functions and linear functions specifically. We know that there's one specific form that tells us the slope and the y-intercept. We know that m represents the slope once we isolate the y variable, and we know that b represents the y-intercept. So let's go ahead and solve this equation for y, and that will tell the tale. So we're going to take our first thing we need to do in the opposite of the order of operations is add and subtract. So we're going to subtract this value 6x from both sides. One of the things that I see frequently is us trying to combine those two terms, but we can see that one is numeric and one is algebraic, and they don't combine. So we just leave that expression as negative 6x plus 30. Well, we haven't isolated y yet. We still have multiplication to undo, and we understand we are dividing everything by negative 5. And that gives us our final form of the equation. Negative 6 divided by negative 5. I am going to leave that as an improper fraction because it tells us exactly what we wanted to know. The slope of this line is 6. That's rise 6. The change in y, the up and down axis, rise 6 over run 5. Both of those values are positive. So the change in y, the up and down, the change in x, the horizontal or side to side, rising 6, running 5. I want you guys to check it out, problem number 4. I want you to work that out entirely, show me all steps, and bring that to me to get that checked off. Once you're done with that, we're ready to work on the lesson. The lesson is this, 11 through 20. You can also find this on PowerSchool, and 22 through 37. Cheers!